just looking into this pole position board that had the graphics problems, the video board of it. And I thought what I'll do is I'll check all the EEPROMs. So I've worked through a couple of them and discovered that they're actually, if you look carefully there, they're actually pole position 2. Now, I could have probably saved myself a little bit of hassle there, because there's a sticker I've seen in here and somebody's bad scroll on the bottom here that does actually say pole position 2 on it. And the same with this one. So what I have here is an Atari pole position 2 board set by the look of it, original, or it could be a pole position 1 converted. But I've got that paired up with a pole position 1 CPU board, so no wonder I'm going to get problems, because all the EEPROMs and everything and the customs are going to be, some of the customs and stuff like that, the PROMs are going to be wrong. So we're going to abandon this at this point. At least we know this graphics board now will boot up after I change that RAM that was on it. Where's the RAM? Somewhere here, there. Now we know that that's working. Then I'll try and find the short on this board and then proceed from that point onwards. There's no point me trying to work with effectively a bad set. What I might go and do is get the board stack out of our upright pole position and stick that the CPU board against this one and see at least where the video board really is at from that point. So that might be a job I'll do later on today. For now, I'm going to go and do some yard work in the warehouse. On the repair bench this afternoon, after breaking our backs doing a container unload, we've got a vector monitor with a poorly HV circuit. So we've Frankenbenched it, and Anthony's over there filming for the legal record in case it kills me. So if you've seen this blog, it probably didn't, and if let's move some tools.
So you've seen it on RGP too.
Yeah.
In which case I uploaded it because it's fun.
Yes. In many replays, I'm going to guess. Multiple simultaneous replays from different angles. Turn that out of the way. Anyways, just clearing the bench a little bit. So this is a Franken rig where we tape the anode cup into a jam jar. Now this is either going to work or that fuse is going to blow. So I found an absolute shit ton of dry joints on the bottom of the circuit board, and that fuse was dead. So I have got the bench meter hooked up over there with nothing on at the minute, and I've got it set into standard mode, so it's putting out 25 volts, which is what this supply requires DC. For those of you who don't know, the monitor itself requires 27 volts approximately centre tap, so 27027, plus or minus 15% of that. And then it has that big thing in the middle there with the caps on, and there's 2 transistors on the other side, so the heat shields are a regulator board, and that generates 25 volts DC for this, which comes into pin 7 there, pin 8 there, and pin 7 there. Let me just double check with the schematic that we got that right. Pin 8 is 25 volts, pin 7 is ground, and it has a 1 amp fast blow fuse. So I'm going to point that at that, and I'm going to switch on. It's either going to work or it's going to pop the fuse. So, well, it hasn't banged the fuse that I can see. And the meter is drawing 0.2 amps at 15 volts. So there's been a bit of a voltage drop. Okay, well, 0.4, 0.7. There we go. So what we're going to do now is we're winding the current limiting up such that it should be able to output. We'll soon know, because it should be measuring its current draw, and we're at 24 volts now, which is near enough, and we're stable at 0.7 of an amp. Okay. Well, that's a good sign. Stable at 0.7 of an amp, draw at 25 volts DC in, and it hasn't popped the fuse. Now the other thing I can't tell you is it doing anything? What I'll need to do is hook up a meter to the output and see if I'm getting 90 volts and 200 volts on the outputs, which is what I'm expecting. So let's do that. I don't think there's any... Oh, hang on. Ooh. I don't know if you can hear that. But it's... Yeah, I can smell the Corona. So I think we fixed the HV. I'm turning that off. So, yeah. Yeah, I can definitely smell the corona that you get from high voltage. Hopefully we'll get a dual angle shot of this in a bit. So we need more cameras. I need some above shots like that. You know, Anthony's a professional cameraman and I don't have a decent camera rig set up and like multi-view switching. It's coming, it's coming. Right, okay, well, let's pop this HV back in the monitor and see if it'll boot up. But, replaced fuse, reflowed absolute shit ton of dry joints underneath, reseated the transistor that's on the side. Let's see where else we get. Just thought I'd show you one more thing. So what I've done is I've flipped it over onto its back. I just wanted to prove that we've got the right voltages coming out. So I'm going to power it up again. Same settings. Out of that third pit, well, what you can see under there is 1, 2, 3, which is actually pin 5. We've got 128 volts coming out. That would be unloaded. So I would expect that to drop to 90 when there's a load on the other side of it. So I'm reasonably happy that HV unit is now probably working. That might be a little high. You never know. But we'll see when we plug it back into the cage over there and see what happens. Right, we've got a Franken monitor set up. So in the last part we were talking about the HV cage and putting it all back together and everything. I'd like to just correct something that I've discovered. So in the last part I was talking about the 90 volt line and the fact that it was 100 and something volts, 116, 120 volts without any load on the back end of it. That's completely utter twaddle, as I've discovered. The 90 volt line without load should probably only really be about 96. What I discovered is that it wasn't adjustable. I did a reading off hours over here and found that hours is at 88. And this is now running to exactly 90. And it turned out to be, and I'm going to try my best not to touch it. If I use a pen, I can't get a shock off it. It was this transistor here, which was causing the problems. The collector and emitter were shorted together on it, which wasn't allowing it to regulate. What's happening is, if I connect, that's the yoke input, the output. If I connect the yoke up and connect the Y output on its own, nothing on the X output, I will get vertical deflection. If I connect both sides of it, I will get nothing out of this side, even though the transistors are good. Because I can connect the same pair of transistors, you can connect them to either side. That's the trick that you do with these. If you've got one side's collapsed, switch the wire over. They will actually reach whilst it's in situ, by the way. If I had this kind of connected with the yoke, this resistor here, this bleed resistor, would start to get stupendously hot and smoke. There is obviously a short somewhere in the X amplifier side, which is this left-hand side of this board, and that's what I'm going to be investigating next. But what I needed to prove was, because it has happened occasionally, it's very unlikely, but what I wanted to prove was that the yoke itself was not dead. And if you look over here, what you'll see is this tube is absolutely perfect. Now I have another issue to solve, which if I zoom in, sorry, I've got to put my hand in front of it. If I go in there and you look at the numbers, they don't have jaggies on them. If this deflection board is plugged into our monitor over here, we get jaggies. So the tops of the letters always out. Now I would imagine that's going to be some ripple then from the power supply, and it probably wants recapping and something else. So at least it tells me which components to start looking at. Our HV section on this, by the way, is absolutely fine. But that means then that all I have to do now is find the short on this side of the board somewhere, or the failed component. Actually, it's nearly 7 o'clock, so we're getting nearly 18:55. Thanks, Milton Keynes. Tonight. So this is coach C. Taxi. You can see the distance. That's where I've got all the way down. I think it's a great place. Bloody Londoners get the first class at the platform enders. Plotting the north, have to walk all the way down to the other end. I can actually walk all the way to Milton Keynes. you feel sick, you can use camera stabilisation mode. Let's walk down this side instead. So we're going to see if we can get my favourite seats on Coach K. Let's go. H. Ooh, haven't got far to walk. Excellent. Geeks, isn't it? If I've timed it right, everybody else will still be up in the lounge, and I should beat the woman with 67 suitcases to Coach K, which is my favourite. I don't think so. Have we? Done it. What have we got in store on the menu tonight? Comfy chicken, layered veg pie, wild mushroom risotto, chips and dips, poached salmon. Comfy chicken, I think. Comfy chicken.
Oh yeah, look at my story.
I don't know what's going on here. You seem to sort of walk out and lie down in front of us. I should have caught the beginning of it. I'm playing IT bitch today.
Sorry?
I'm telling the viewers what I'm doing. I'm being IT bitch. Apparently you need an instruction manual to install a network switch. Because I'm doing it. Mrs. RGPs. Wave hello to everybody. Or give them a finger or something, I don't know. She's got one of these Virgin Super Hub things. I think the word super is very overused in it. Anyway, Wi-Fi keeps dropping out, so we're trying to make it that the Apple TV can actually work, because the Wi-Fi keeps dropping the IP addresses. So we've got one of these. I mean, I could have brought these 48 port Super Hub with power over Ethernet on it and everything, but that means another one of these wall water things behind the telly. And that.